In this video session, we shall discuss some topics in the mathematics of finance. We shall discuss the concept of simple interest. We shall discuss the concept of compound interest. We shall derive the formula for compound interest. Then we shall solve some examples in simple and compound interest. When we talk of simple interest, assume you have a savings account in a financial institution. A financial institution could be a bank or credit union. The initial money you deposit in that savings account is what we know as the principal or investment. After some time, say T, the bank will give you some interest. The account will earn some interest according to an interest rate, say R. That interest is an extra money the bank will give to you. The bank will deposit in your account. Your account will earn some extra money after some time T, according to a rate R. That extra money is what we know as simple interest or dividend or yield or return. So similarly, now how will your account earn interest? The bank would trade with your money. The bank or the credit union, they would trade with your money. They might loan your money to a business. When the business pay back that loan, they also pay an interest. So when the bank loans your money, they charge interest according to an interest rate. The business will pay back that loan with interest. Then the bank will take some of that interest and give to you because they used your money. So when you talk of interest, it could be when you deposit. When you deposit money, then you earn interest. When you borrow money, then you pay interest. You are charged interest. So it goes both ways. And the formula, you can review the teacher-student scenario. So the formula for calculating this interest is principal times rate times time. The principal could be the amount you deposit or the amount that is borrowed, the amount you deposit in your account or the amount that the bank loans to the business. Now, let's look at compound interest. Let's look at an example of simple interest. Before we go to compound interest, say you deposited an initial sum of money, $1,000, in a financial institution that has an interest rate of 10%. How much would you have after 3 years? This is a table that illustrates that at the beginning of each year, your principal is $1,000. So you multiply it, 10%, interest rate is in percent. You convert to decimal. 10% is 0.1. Then each year times 1 year. And the simple interest will be $100 at the end of each year. So at the end of the first year, you have $1,100. At the end of the second year, you have $1,200. At the end of the third year, you have $1,300. Because you keep adding, the amount is the interest plus principal. Okay, so when you add the interest plus principal, it gives you the amount. So 1,100 plus 100 is 1,200. 1,200 plus 100 is 1,300. So you see the principal is the same at the beginning of each year. But when we compound that interest, compounding the interest, we see that the principal at the beginning of the second year is the amount at the end of the first year. Okay, the amount at the end of the first year is the principal at the beginning of the second year, as you can see here. And the amount at the end of the second year is the principal at the beginning of the third year. So when you compare simple interest versus compound interest, after 3 years, you find out that compounding the interest gives you much gives you more money. Okay, so that's a difference of $31. So I encourage you to read the teacher-student scenario, and from here you can derive the formula for compound interest. You can actually derive the formula here algebraically. So let's go ahead and do some examples. Now remember, with compound interest, you're compounding it. And with this example, we compounded annually, which means every year. However, you can compound semi-annually, twice a year. You can compound quarterly, which is 4 times a year. That's every 3 months. Now, when you hear of the quarterly GDP report, GDP growth quarterly report, if you listen to the news, to NPR news, when you compound monthly, you have 12 times a year, which is every month. Compounding weekly is 52 times a year. Okay, and like I said, we just derived the formula from that, and this is the formula here. A is the amount, P is the principal, R is the interest rate, M is the number of compounding periods per year, and T is the time. So I'm going to give you the formula. So what I expect you to do is to know how to use the formulas. Okay, but I give my students formulas, and then I expect you to just know how to use them. Okay, so let's do some examples. For simple interest, we are going to do example 5, question 5, and later you can look at these examples. Mr. Michel deposited $40,000 in a bank and earned simple interest at 7% per annum for 2 years. Calculate the amount he will receive at the end of the 2-year period. So in this case, P is 40,000. We know P. R is 7%, which you convert 7 divided by 100 gives you 0.07. And T is 2 years. So we are looking for A. So we know P, we know R, we know T. Now we are looking for A. And like I said, I'll give you the formulas. So you look for A. Remember, you know P, you know R, you know T. So this is the formula you're going to use, number 7. Okay, because you're looking for A. Okay, and that is it right here. And that gives us 45,600. Let's do for compound interest. For compound interest, let's do question 1, ACT problem. Now, some of these questions are questions from exams. So here, when a bank pays I% interest compounded annually, a deposit of P dollars increases to this. That's the amount. At the end of Y years, where Y is a whole number. Lou initially deposits $600 in an account that pays 4.75% interest, compounded annually. Lou does not make any further deposits or withdrawals. How much money in dollars is in Lou's account after 8 years? So here we are given the P. The P is just the P, which is 600, the principal, that's the initial deposit. The interest rate, R, is 4.75%. You divide that by 100, 0.0475. Compounded annually means that M is 1. Then T is 8 years. You're going to use here. That's the amount, is what they're asking for. So, as you can see here, P is 600. I is 4.75 divided by 100 is 0.0475. And then Y. Remember, this is an exponent. Y is 8 years. So this will give us this here, D.